Section 1.6, Functions. This is a section that's a very commonly missed section for a lot of students, but it's another one of those, really, that's all I had to know, that's all I had to do type sections. So don't worry if you're one of the many that kind of didn't do so hot on this section. We'll get you fixed up pretty quickly. This picture here, this is actually one that I took, and this is in the Arc de Triomphe in Paris, France. And if you aren't sure what that is, that's what the cyclists ride through at the very last end of the Tour de France. It's like the big giant archway in the middle of Paris. And this is climbing up a spiral staircase, and the next picture I actually have in the sequence is Miss Lofting, whose arm is right there, peeking over the edge. So let's look at a couple vocabulary words first. A function, it consists of a couple different pieces. Firstly, it consists of the domain. The domain, you're talking about the set of inputs. So think of the IN in domain and the IN in inputs. It's what you put into the function. The range is your set of outputs, or what comes out of the function. Couple of notes. In a function, each input is paired with exactly one output. However, an output can be paired with multiple inputs. Now, I taught functions this way for a really long time, and yes, it's the correct way to teach it, and it does explain it, but it's a really hard concept to grasp. And about 2-3 years ago, I came up with the vending machine theory. And for the vending machine theory, it goes as follows. You're going to think of functions like a vending machine. If you press C1, you get a Snickers bar. Every time you type in C1, a Snickers bar should come out if it's functioning correctly. If you suddenly get an Almond Joy, the function is not, or the machine is not functioning properly. So that's the same kind of thing with functions. Each time you put in the number 3, you should always get 7 out if you get 7 out the first time. We're going to skip this one. Well, no, we'll go ahead and do this one. So we've got Miguel on his job, and the input is the number of hours, and the output, or the domain, the input is his number of hours, and the output is the dollars. We're identifying the domain and the range. For this one, think of your input or your domain as that little annoying brother or sister. Well, Miguel, how much money are you going to earn if you work 2 hours? What about 5 hours? What about 7 hours? What about 8 hours? They're just really, really questioning a lot about different situations. So our domain in this case is 2, 5, 7, and 8. Our range is just what you would answer those questions, or how you would answer those questions. So our range is 14, 35, 49, and 56. And that's all you have to do for this problem. Let's look at this one. One of these is a function and one of these is not. Let's go back to our vending machine analogy. If I put in 1, I get out 0. So if I put in A1, I get out Snickers. If I put in A2, I get Pringles. If I put in A3 and if I put in A4, I get Reese's Peanut Butter Cups. With this one, I put in A0 and I get Snickers. I put in A1, I get a Reese's Peanut Butter Cup. I put in A1 a second time and I get Almond Joy. And I put in A2 and I get Almond Joy. One of these is a function and one of these is not. With the model on the left, putting in 3 and 4 both results in an answer of 2. So in our vending machine, that's like having 2 rows with the same product. And it's okay to have 2 rows of the same product. In our building, we really like Reese's Peanut Butter Cups, and a smart vending machine filler upper guy would probably think to put in a couple rows of Reese's Peanut Butter Cups because we'd buy them. Over on this side, though, we put in A1 and we get 2. Then later on we try A1 and we get 4. That vending machine is not loaded properly because you've got 2 different items in the same row. So this one on the left is a function. And the one on the left is not a function. I'm sorry, the one on the right. The one on the right is not a function. Your turn to try. One of these is a function and one of these is not. Pause your video at this time and you decide which is the function and which is not. The top one is not a function. The bottom one is a function. If you got it right, draw yourself a little cat face. Hopefully yours is a little bit more round and a lot less fluffy / fat than mine. We'll have to see. If you didn't get the correct answer, go back and try it again. Our last piece of this section is writing rules for functions. Looking at this function right here, recall that the input is our x value and the output is our y value. So we want to write an equation where we've got y equaling something happening to x. So let's see, I've got 14, 35, 49, 56. So for this, 14, 35, 49, 56, those are all multiples of 7. So let's see if something will work with a 7. So let's see, 2 times 7 is 14. If I multiply 5 times 7, that's 35. 7 times 7 is 49. And yeah, 8 times 7 is 56. So that all works out. So my equation is going to be y equals 7 times my input, or y equals 7x. It's not wrong to write that in reverse and to say y equals x times 7, but it's kind of like talking like Yoda. It kind of talks backwards a little bit. Again, it's not wrong, but the proper way to write it is going to be y equals 7x. And really get in the habit of putting that 7 or that coefficient in front. It's going to make life a lot easier later on. Here's one for you to try. Pause your video at this point to figure out the rule to get to the output from the input. Did you get y equals x minus 1? If you did, give yourself 3 stars. If you didn't, give yourself an X, go back, figure out your mistake, and circle it once you've figured out what you did wrong. Your problems for homework tonight are on page 38 and 39, numbers 14 through 10 even, 20 and 21.